Dear students, this is my 7th video. Here in this video, we are going to discuss some more problems, solving the few more problems on linear differential equations of second order with variable coefficients of the type d2y by dx2 plus p into dy by dx plus q into y equal to r. Okay, let us see one example. You see the sixth example. This is solved by the method of variation of parameters. Here equation we are discussing solving by variation of parameters. You see that equation is y2 minus y equal to 2 divided by 1 plus e raised to x. Take down the given equation is y2 minus y is equal to 2 divided by 1 plus e raised to x. You call this equation as 1. Here left hand side it can be written like this: d square minus 1 into y equal to 2 divided by 1 plus e raised to x. Here r is r equal to 2 divided by 1 plus e raised to x. In this example p is 0 and q is minus 1. Here you say that this is very simple. This is very simple to find the complementary function here. Okay, take down the auxiliary equation m square minus 1 equal to 0. This implies m is equal to plus or minus 1. So complementary function is c1 into e raised to x plus c2 into e raised to minus x. Now let y is equal to, use variation of parameter method. Replace c1 by a1, c2 by a2. a1 y is equal to a1 into e raised to x plus a2 into e raised to minus x be the required complete solution of given equation. You call this as equation 2. Here u is comparing, already theory we have discussed. Here comparing u equal to e raised to x and v equal to e raised to minus x. Therefore derivative of this u1 is e raised to x, v1 is minus of e raised to minus x. So very first you find out w Wronskian w equal to second order determinant, first row uv, in the second row u1 v1. So in the first row e raised to x, e raised to minus x, in the second row derivative of its derivatives e raised to x minus e raised to minus x. So after expanding this determinant you get minus 1 equal to minus 2 you get. So by using laws of indices you get like this minus 2. So now you find out the a1 value and a2 value. a1 is given by the formula minus of integral into vr divided by w into dx. Substitute minus into integral of v you substitute, v is e raised to minus x and r is 2 divided by 1 plus e raised to x here, divided by Wronskian w value is minus 2. After simplifying we get this is a dx divided by integral of dx divided by e raised to x into bracket 1 plus e raised to x. So here you can integrate this, find the integration or integral of this. So here use substitution method. Now put e raised to x equal to z. So they differentiate both sides with respect to okay, e raised to x dz by dx you find out, or e raised to x into dx equal to dz you get, or dx equal to separating the, you can separate the variable dz by e raised to x and e raised to x is replaced by z, dz by z. So in the place of dx you write dz by z and in the place of e raised to x you write z. So a1 takes the form a1 equal to integral of dz by z divided by z into bracket, in the place of e raised to x you write z, z into bracket 1 plus z equal to integral of dz by z square into bracket 1 plus z. This is equal to, you can write in the numerator, make it is integrable. This is not easy to integrate, make it is integrable. So in the numerator plus z, adding and subtracting z and z square You can do that. That is 1 plus z minus z square plus z square dz. You can write. So next step, you can a1 equal to, this is equal to integral of, you can group it 1 plus z, you write in one bracket. So here minus z into bracket, here you can take minus z common, you get minus z into bracket 1 plus z here plus z square, write as it is. Okay. If you divide separately, you get 1 plus z get cancelled, here 1 by z square, here 1 plus z cancel, z by z square is 1 by z plus finally in the z square get cancelled, 1 divided by 1 plus z remains here. This is as if you can by resolving into partial fractions you can say, but here you have used another method, here adding and subtracting z and z square. So this can be resolved into partial fractions. Okay. So now these are all easy to integrate. You can write a1 equal to, the integration of 1 by z square is minus 1 by z, then minus the integration of 1 by z is log z plus 1 by integration of 1 by 1 plus z is also log of 1 plus z plus c1. Okay, this is a1 equal to, substitute back, z is replaced by e raised to x, whatever you have taken substitution back, substitute back, minus 1 by e raised to x minus of log e raised to x plus log of 1 plus e raised to x plus c1. Simplifying, you can write in numerator minus e raised to minus x. So here log and here log and e raised to x are their inverse operators, they are inverse of each other. So you get x here minus x plus log of 1 plus e raised to x plus c1, right as it is. Okay, this is the value of a1 here. Similarly, a2 you find out, a2 is given by the formula integral of ur into ur divided by w dx. Substitute u means substitute integral of e raised to x, u value e raised to x, r is 2 divided by 1 plus e raised to x divided by w value is minus 2. So after simplifying we get minus of, this is a 2 get cancelled, minus of e raised to x minus of integral of e raised to x divided by 1 plus e raised to x with respect to x dx. So this is very, because the numerator is the differentiation of denominator, so log of denominator, right, minus of log of denominator is 1 plus e raised to x plus c2 you add. Okay. Then with these two values of a1 and a2, then equation 2 implies, substitute the values of y is equal to, this is the value of a1 minus e raised to minus x minus log minus x plus log of 1 plus e raised to x plus c1 into bracket e raised to x plus the value of a2 is bracket minus log of 1 plus e raised to x plus c2 into bracket e raised to minus x. You can multiply inside, you can write complementary function separately, c1 into e raised to x plus c2 into e raised to minus x. Remaining whatever left here, you can write multiplying e raised to x into e raised to minus x gives 1, it is minus 1 you get, minus x into e raised to x plus e raised to x into log of 1 plus e raised to x. Here in the second bracket, from second bracket minus of e raised to minus x into log of 1 plus e raised to x. This is the required general solution of given equation. Similarly, one more example, you see that example 7 solved by the method of variation of parameters. Equation is x square into d2y by dx2 plus x into dy by dx minus y is equal to x square into e raised to x here. Given equation is, write once again this, here actually homogeneous or Cauchy-Euler equation actually, but they ask to solve this equation by method of variation of parameters. You must and should apply this method only. Here you can using for complementary function you can find out, you can Cauchy-Euler equation method, you can you use method write in the symbolic form here, find out the complementary function first, but here not given, it is not easy to find here complementary function. So here you have to using Cauchy-Euler equation method. First you have to reduce this is into linear differential equation with constant coefficients. So you can write in the symbolic form x square into d square plus xd minus 1 into y equal to x square into e raised to x. This you call as equation 1. This is a Cauchy-Euler equation. Therefore put x equal to z, you know the method. Put x equal to z, z equal to log x. xd is replaced by d1, x square d square is replaced by d1 into d1 minus 1, where d1 stands for d by dz. So then with this transformation, equation 1 becomes d1 into bracket, in the place of x square d square you write d1 into bracket d1 minus 1 plus d1, xd is replaced by d1 minus into bracket y is equal to e raised to RHS side x square, in the place of x you write e raised to z, so it becomes e raised to 2z, and in the place of e raised to x, x is replaced by e raised to z, this takes the form e raised to z. So on the RH left side you can simplify this, you can get, this implies that d1 square minus 1 minus d1 plus d1 get cancelled, so d1 square minus 1 into y is equal to RHS side e raised to 2z e raised to z. Here r is this one, e raised to 2z into e raised to z, or in terms if you want to substitute back, you get x square into e raised to x is the r here. So you have to write auxiliary equation. Now you can find out auxiliary equation, m square minus 1 equal to 0, m equal to plus or minus 1. So complementary function you get in terms of z, you get c1 into e raised to z plus c2 into e raised to z. Now substitute back, you get complementary function c1x plus c2 into x raised to minus 1. Okay, here then you can apply method of variation of parameters. Let y equal to, after finding complementary function, to find particular integral you can use this method of variation parameters. Let y is equal to a1x plus a2, c1 is replaced by a1, c2 is replaced by a2 into x raised to minus 1, and this you call as equation 3. This is the complete solution of equation 1. So here u equal to x, v equal to x raised to minus 1, so u1 is 1 and v1 is minus x raised to minus 2 or minus 1 by x square, minus, or you can write either minus x raised to minus 2. So w Wronskian w find out, w is given by determinant of uv, in the first row uv, in the second row u1 v1. So write x 1 by x, the derivative of x is 1, derivative of 1 by x is 1 minus 1 by x square. This is equal to, if you expand the determinant, you get minus 1 by x equal to minus 2 by x. This is a w value. So a1 is given by the formula minus of integral of vr divided by w into dx equal to minus of integral of, if we substitute 1 by x, the value of v here, if you given equation, if you write in the standard form, v, this is the here v, you know that v1 x raised to minus 1, that is 1 by x, v value is 1 by x, and r is already I have mentioned about x square into e raised to x, okay, divided by w value is minus 2 by x, okay. After simplifying we get this is a 1 by 2 into integral of x square into e raised to x. Using by parts, integral by parts, you can use that first function, second function. First function is x square, second function is e raised to x. So 1 by 2 keep as it is, first function into integral of second e raised to x minus integral of derivative of first is 2 raised to x into integral of second e raised to x dx plus c1 you write. Again you apply 1 by 2 into bracket x square into e raised to x. Again you apply the integration by parts to this, already okay, this is over, as it is you write this is. So first function keeping as it is minus 2x, integral of second function is e raised to x, minus plus 2 is keeping as it is, integral of derivative of first is 1 into integral of second e raised to x dx, close the bracket, plus c1 you write. So simplifying all this, you get a1 equal to 1 by 2 into x square into e raised to x minus 2x into e raised to x plus 2 into e raised to x bracket plus C1, you write. This is A1 value. Similarly, A2 is given by, find out A2 value. A2 is given by integral of UR divided by W into dx. So, integral of U value is x into x square into e raised to x, that is R value, divided by W value is minus 2 by x into. So, after simplifying we get minus 1 by 2 integral of x fourth into e raised to x dx. Okay, using using generalized rule of integration by parts, you can use the generalized rule of integration by parts. If you go like above, it takes more time. You can use the generalized rule of integration of by parts. Here you get a2 equal to minus 1 by 2 into square bracket. Go on differentiate the first function and at a time integrate the second function. So go on using use alternative sign. Okay, first x fourth into e raised to x fourth into first function into integral of second minus derivative of first 4x cube into integral of second plus 12x square derivative of first function into integral of second function e raised to x minus 24x into e raised to x 24x into integral of second e raised to x plus 24 into e raised to x. Continue up to first function become constant, you can stop the procedure. Okay, plus C2. Okay, this plus 24x, you close the bracket, plus C2. Okay, so this is the A2 value. Okay, then 3 implies, equation 3 implies, substitute all the values, A1 value and A2 value here. This is A1 value into x. Okay, then A2 value just you got to substitute here into 1 by x, that is v, u, v. This is u and this is v, 1 by x. If you simplify, you get multiply all the brackets, you remove this. Finally, you get this x into x square into e raised to x minus 5x into e raised to x plus 12 into e raised to x minus 12 by x into e raised to x plus c1x plus c2 by x. This is a complementary function. Whatever this is, the terms which are free forms or arbitrary constant, these are particular integral. Okay, and this is the final solution, complete solution of given equation. So these are the similar type examples for practicing for you. So practice these examples, solve by the method of variation of parameters. Y2 plus y equal to cosec x. Answer I have given here c1 cos, separately I have given c1 cos x plus c2 sin x. This is the complementary function, minus x cos x plus sin x into log sin x. Similarly, example 9, solve by method of variation of parameters. Y2 plus y equal to sec x. So solution I have given c1 cos x plus c2 sin x plus cos x into log of cos x plus x into sin x. So in example 10, solve by the method of variation of parameters. X square into y2 plus x y1 minus y equal to x square into e raised to x. This is just like above example. You can follow the above method. You get this. The final answer is y equal to, answer may be y equal to c1x plus c2 by x plus e raised to x into bracket 1 minus 1 by x. Okay. Well, okay, with this I will stop okay here. In the next video we can going to discuss few more examples, different examples we are going to discuss. Okay, thank you.